This is a battery, or you call it a cell. There is so many questions and calculations involving this battery, which I will treat. It is 10 of them, technically and differently. This battery now gives energy. It gives current to electrical appliances. The amount of current that this battery can give depends on electromotive force of this battery and the internal resistance of this battery. It depends on the electromotive force of this battery and the internal resistance of the battery. The internal resistance of this battery is opposition to the current that this battery can give. It will try to stop the movement of the current out of the battery. So if the resistance is too much, is too high, then the current that this battery can give will be smaller. But if the resistance is small, then the current that this battery can give will be much. So electromotive force of this battery is the potential difference across this battery. It is the potential difference across the terminal of this battery. The terminals of this battery is here. Here is positive and here is negative. If you want to measure the electromotive force of this battery, which is measured in volts, if you bring voltmeter, you put one wire at the negative terminal and put another wire at the positive terminal and read the electromotive force of this battery. It will read on the voltmeter, which this one is 1.5. Okay. Now, then this electromotive force is the force across the terminals of this. It is the energy of this battery to push current. Now, when this battery is connected to a circuit, just like when you put this battery in a torch, you have connected it to a circuit, then you on the torch, it will start giving light, right? Now, the total E.M.F now will now become the potential difference across the external resistance, which is the light it owns, plus the potential difference across the internal resistance, which is the internal resistance in this battery. Look at it. The E.M.F is equals to terminal potential difference plus lost voltage. Terminal potential difference is, look at the circuit where I drew it. This is a battery. This battery has internal resistance and the electromotive force. So if this battery starts working now to push current across this circuit now, there will be a potential difference here. There will be a potential difference across this external resistor. This one is external, is no longer in the battery. This one is the one that is in battery, small r, then big R is the one outside the battery. So the potential difference across here is what we call terminal potential. Then the lost voltage is the lost voltage is the voltage across the internal resistance of the battery. That is what we call the lost voltage. Because this voltage does not involve in the work across external voltage. This lost voltage will not involve in the work here. This lost voltage is only involved in internal in order to conquer this internal resistance. You know, internal resistance tries to oppose the movement of the current. It tries to oppose it. No, current, you are not going anywhere. But due to the manufacturer considers that and give this battery the electromotive force that can push current, that can deal with the internal resistance, also push it outside. Understand? We now consider the lost voltage, that is the voltage that will deal the resistance is the voltage that will deal the resistor in the battery before now coming out to deal with this, with the external one. So the total EMF now will now be the potential difference across internal resistor, which we call lost voltage, plus the potential difference across external resistance, which we call the terminal potential difference. If you want to calculate that for the terminal potential difference, it is equal to current times resistor. It is now equal to current entering this resistor here times the value of the resistor using Ohm's law. Then for the lost voltage now, in order to calculate for the lost voltage, it will be current entering the internal resistance of the battery times the value of the internal resistance, also Ohm's law. So that will now give us the EMF of this battery when it is working. There is a lot of questions which I have said before. There's a lot of question involving in this cell. I will calculate up to 10 of them. Please make sure you subscribe to my YouTube channel or follow me on Facebook and other social media to make sure you see and participate and know how I solve these 10 different questions concerning this. Thank you so much for watching, and God bless.